Okay, so have a nice day, everyone. So in this video, I'll be going to illustrate to you how to do the Bellman-Ford algorithm. So when we say Bellman-Ford algorithm, that is talking or the algorithm which is used to find the shortest path from a single source node to all other nodes in the graph, and useful for graph that have negative weight edges. So it does allow negative edge. So that guarantees that the correct answer, even if the weighted graph contains the negative weight values, and relaxing all the edges by n minus 1 times. So that means to say we have n minus 1 times of iterations here then. And we still follow the relaxation steps for this. So next, this is to find the shortest path. First step is note down all the edges. So the algorithm that we follow here, we set initial distance to 0 from the source vertex and set the other distance to infinity for all the vertices. For each edges, check if a shorter distance can be calculated and update the distance if the calculated distance is shorter. Now, next, you will check all edges step 2 by v times 1, v minus 1 times. This is many times as there are vertices v minus 1. So optional, we check for negative cycle, iteration is n minus 1. So the best case, average, worst case is big O notations of E for the best case and big O notations of vertex E for the average and the worst case complexity. Now, let's go to move on to the Bellman-Ford algorithm. This is actually a directed graph. It is not for undirected. So since the undirected graph, it will takes a lot of process. So that's why I will make sure that it will be easier for you, everyone. Now, so the first step that we will be going to do, we will, as what being mentioned, that you have to gather all of the sequence. So all of the steps, AC, because in undirected graph, you will transform that into a directed graph so that each path or sequence, you can follow that one. So that will be AC, AB, AD, BE, CD, CE, ED. So that's how you will do it. So in the first sequence right now, first iteration for the step 1, you will do then step 2, step 3, step 4, step 5, step 6, step 7. So we have here 1, 2, 3, 4, 5. So we can have 4 steps in this one. Okay. Now, for this one, 4 steps, 4 iteration, but the step will be this one. This will be the step. Now, for the first iteration, step 1, we follow the AC. For AC, that is 0 plus 10. So we update here. Second step, A, B will be 0 plus 8. That is 8. Updated here. Next step, AD, that will be 0 plus 9. It will become 9. So BE, that will be 8 plus 36. That will be 44. B, CD afterwards, that will be 10 minus 2. That will be 10 minus, that will, as what I mean, so since that is 10, minus 2, that is 8. So 9 is greater than 8. So we updated that into the shortest path. Now, afterwards, CE, that will be, CE is 10 plus 1 is 11. So 44 is greater than 11. So we update that to 11. ED will become 11 to 20. That will be 30. No. Yes, that is 31. So that was not, that is still not allowed. Now we already have the step 7 for iteration 1. We keep on doing that for all the sequence. The step 2, second iteration, we will do all the steps already in one pattern. since with respect to the time as well. But in your calculation, you will do that in step-by-step manner, but I will allow you to do that for the iteration. I will allow you to do the iteration, but the step for each iteration, I will allow you to do the first iteration, but all of the iteration must consist all of the steps. But the second iteration, third iteration, fourth iteration, um, you can put all the steps already. I will allow that one. Now, for this one here, AC is 0 plus 10, no update. AB, that will be 0 plus 8, no update. AD, that will be 0 plus 9, no update. Since we already updated that into 8. BE, that is 8 plus 36, no update. CD, that is 10, minus 2, no update. CE, that is 1, 10, 1, no update. 11. ED, that is 11, 20, no update. So we already done with the second iteration. For third iteration, we put here the same thing. So there's no update anymore. And for the fourth iteration, you just keep on doing that repeatedly. So it's okay. That's all for the Bellman-Ford algorithm. But don't you worry, I will be going to allow you to, I will be going to just give you a what we call this one, a directed graph. In that way it will be easier for you, because for the undirected graph you will transform that or convert that into a directed graph first. For example, C to E, if they're undirected, so you will put here C to E and you will put E to C. You will transform that first into directed, so that you will not be going to have any hassle in the future. So that's how you will do the Bellman-Ford algorithm. So thank you so much, and let in the next video we'll proceed to another um data structures already, since this will be the last topic for the graph data structures. Thank you so much.